In this video, we're going to do some basic network scanning in the graphics lab. First, open the Kali container and then open a terminal. And the first thing we're going to do is just try to find our own IP address. So do ifconfig. And then this bottom IP address you find is just localhost, and then the top one's kind of an internal thing. What we're interested in is this middle one, 192.168.90.6. So that's our relevant IP address. And to get a little bit more information about what subnets are available to us to scan, let's run netstat and then -rn to display some routing information. And we can see that this 90 subnet is one we're connected to, but also through probably a router at 90.200, we're connected to this 95 subnet. Before we move on from here, I need to emphasize that active scanning of ICS networks is not necessarily safe. Only do active scanning with Nmap on an ICS network if you have permissions and if you're sure that it's going to be safe. Otherwise, try to do passive scanning or something else. But for this lab, we're going to be doing some active scanning because there's not really any risk of anything going wrong. So to scan both of these networks for potential ICS devices, we're going to use Nmap. So we're going to do Nmap and then specify, for the purposes of this video, not a complete list of ICS ports by any means, but just some common ports used by ICS protocols: 502 for Modbus, 44818 for Ethernet IP, 20000 for DNP3. And then we're going to scan both of the subnets that we think we have access to. And we're going to use the /24 because the net mask was 3 255s. And just to keep the results cleaner, I'm only going to show open ports with --open. What we find is that we found some 502 ports open, which is typically what Modbus uses, and that's in the 95 subnet. We got .15 through .10 and also .2, and that's all we found. So it doesn't seem like there's any ICS devices in the 90 subnet. What we're going to go ahead and do is do just the most basic Nmap scan you can of the 90 subnet to see if there's some sort of other more typical IT devices there. And we find a few devices, and you can kind of cheat because they have these like internal names for Docker where we can tell which one is the router, which one's Caldera, which one's Kali. But you can also look at what IP address they have and what port they are, and maybe try visiting them in a browser. So in this case, we've got, let's try the top one, 90.107 and port 8080. So you can go to the browser and 192.168.90.107, and then a colon, and then 8080 for the port. And we can visit that, and we see that we found SCADA LTS, which is our HMI. We can do the same for the others. For the 200, and then the port for 200 was 500. And then we can see that this is the firewall. And then the next one is 250 at port. It has several ports that are available, but we don't really want to look at Ethernet IP or this other one. We're going to look at the port that's all 8s. And we can identify that a Caldera server is running there. And then lastly, we have Kali, which we can already identify. This is our own IP address that we found earlier. So one last thing we can do is try to identify what these Modbus devices were. And there's various ways you can do this. In a later exercise, we'll do that with Caldera. But for now, let's try Metasploit. Metasploit is an open source penetration testing framework that has lots of tools and modules, and also comes with a command line tool that can be used to run these exploits. The command line tool can be run using the command msf console. And let's search for Metasploit modules that use Modbus. We have Modbus banner grabbing module. This looks like something we can use to identify Modbus devices. So let's try that. And then I'm going to say show options to see what parameters we need to set. And we're going to set our hosts to the range of IP addresses we found were Modbus devices. So that was 10 through 15. And then we're going to run this. And an interesting thing we find is that for every IP address, we find like vendors and product names and stuff like that. But at the end, we find the user app name. And so we see that the 1.15 device looks like it's an analyzer, a reactor at 0.14, product at 0.13, purge, 0.12, feed 2 at 0.11, and feed 1 at 0.10. So feed 1, feed 2, purge, and product might possibly be the IP addresses of the valve actuators that we can use to potentially spoof Modbus commands and change the values of how open or closed those valves are and affect the ICS process.